Hello, Andy Sullivan here. This video will show you how to access and operate a free distillation simulation tool. These tools are used to train refinery and chemical plant operators in industry and colleges. The simulators can be very costly to purchase, so I hope you enjoy this openly accessible simulation I built. You can access the simulation at the link below or by accessing processplantTechnology.com. Click Games and Simulations. Scroll down and click Distillation Simulation. Click on the Start button. Enter your name first. This is important because it is the only time you can enter your name without restarting. Click the Enter button to submit your name. Click Load Low Rate Case. There is a cold start case too, but this is a more advanced starting point. Click Run Simulation. You may pause the simulation on this screen and set the simulation on high speed mode too. Click on Run Simulation to resume normal speed. Close the Start window with the small X in the top right of the submenu. As the operator, you interact with the control system through faceplates. Open a faceplate by clicking on a number displayed on the screen. I will click on the tower overhead temperature, which is about 155 degrees Fahrenheit. This faceplate represents a controller. You can tell it is a controller from the dotted line from the value to the control valve. The controller adjusts the valve position to hold the value at a set point. The instrument tag and abbreviated name are listed at the top of the faceplate. Faceplates can be moved by clicking and dragging in the blue area at the top. Controller terminology is important. PV is the present value of the parameter being controlled. In this case, it represents the present value of the tower overhead temperature. Using your home's thermostat as an analogy, the PV would be the current room temperature. SP is the set point, which is the target value for the parameter being controlled. The operator sets this value. In the example here, the set point is 155 degrees Fahrenheit. The PV is holding close to the set point, but there is a little variability over time. In the home heating analogy, the set point is the temperature you want your house to stay at. OP is the output from the system and represents how far open the valve is that is being used to control the system in this case. An output of 0% represents a signal to close the reflux valve in this example. An output of 100% is a signal to open the reflux valve all the way. Change the value of the set point by clicking on the current set point and changing the number. Be careful not to hit enter until your number is right. Entering a wrong number can upset the process, cause a unit to shut down, or even create an unsafe condition in a real plant. This is called fat fingering a set point. The controller is in automatic mode indicated by the illuminated auto button. The controller will adjust the output to hold the PV at the set point if the controller is in auto. The controller is turned off by clicking on the man button. Man is short for manual from the Latin root for hand. When the controller is in manual, the operator directly sets the output. The output cannot be directly set by the operator in auto because the controller is setting the output. Switch back to auto by clicking the auto button. It is important that the set point be near the PV when you click auto, or the controller may respond aggressively, causing an upset, shutdown, or dangerous condition in a real plant. There are are additional parameters available for the operator by clicking the Detail button, which is in the bottom right. LLA and HLA stand for Low and High Level Alarm and indicate the acceptable range of operation for a parameter. Operating on alarm is not permitted in plants, and avoiding alarms is one of an operator's top priorities. KP, Ki, and Kd are PID tuning constants for the controller and are not changed frequently. Close the faceplate detail by clicking the minus button in the lower right. Close the faceplate by clicking the X in the upper right. The X is only visible when your mouse is near it. Some faceplates are only indicators. The C4- content in the bottom stream is an example. The faceplate only shows the PV and alarm limits. You can start and stop pumps by clicking on them. I will turn on audible alarms by clicking on the Sound On button at the top. Sounds are off by default to be a courteous program, but sounds are on in a plant and will give the operator immediate indication of an issue that needs attention. I will create an alarm by setting the cooling water to the overhead cooler too low. The alarm is indicated by both a flashing red value and an audible alarm. Opening the alarm page by clicking the Alarms button at the top of the screen. The audible alarm can be silenced by clicking on the Silence button at the top of the window. Silencing an alarm does not clear it. It only quiets the alarm once the operator is aware, so the noise is not distracting. An alarm is cleared from the alarm screen when the PV is normal, in the normal range again, and the alarm has been acknowledged by the operator. Acknowledge an alarm by clicking the ACK radio button next to the alarm, or acknowledge all current alarms by clicking the Acknowledge All button at the top of the alarm window. Alarms do not clear unless they are acknowledged by the operator, so the operator always has a chance to observe the alarm. An operator could miss an alarm that was cleared itself quickly, which might prevent identification of a problem. Close the alarm window by clicking the X in the upper right. Open the score summary by clicking on the Score button at the top. Score is earned by the number of barrels of on-spec product you produce in 2 hours. The target amount needed for 100% is indicated in the target column. Score is deducted for every new alarm you trigger. Alarms that were on when you started do not count. Score is also deducted for the length of time you are on alarm. Your objective is to increase rate and maximize on-spec product without hitting alarms. Have fun with it. The simulation has a lot of the features of high-cost simulators that are not available to individuals. You will get a feel for what being a console supervisor is all about in a refinery or chemical plant. This is only a little piece of what a console operator in a plant would run.